You're listening to the Stefan Livera podcast, focused on Bitcoin and Austrian economics. Listen in as I interview the best and brightest, such as Bitcoin software developers, entrepreneurs and business leaders, analysts, economists, and more. This is episode 46 with Bitcoin Core developer Sjors Provoost. He is from the Netherlands and his work on Bitcoin Core is sponsored by the company Blockchain. But before we begin, a quick advertisement on behalf of my sponsor for this episode. BITL Bootcamp is an online Bitcoin programming course taught by former podcast guest Justin Moon. See SLP46 for my interview with Justin. Justin is well known for giving some Bitcoin talks and educating with great reviews from his prior students. In BITL Bootcamp, you will join an online Slack community with other students and some alumni of his course, and together, here is what you can learn. First, you build a miniature implementation of Bitcoin in Python with all major features: peer-to-peer networking, Nakamoto consensus, monetary policy, and more. Deploy the network along with your classmates. Build some simple infrastructure for it, an exchange and a mining pool, and practice attacking it. Second, program the real Bitcoin peer-to-peer network. Connect to peers, send and receive messages, write a crawler that can visit every public node in the network, implement naive headers first initial block download, and build a basic SPV client. Third, build a hardware wallet with MicroPython firmware, just like Trezor. Generate seed words, create HD wallets, construct and sign transactions, and lastly, build a project of your own choosing. The next course begins January 21st and will repeat monthly through 2019. Completion of an introductory Python programming course is the only prerequisite. Visit bitlbootcamp.com to learn more. That's BITLBOOTCAMP.com. Now, on to the interview with Sjors. Welcome to the show, Sjors. Thanks very much for coming on.
Thanks for having me on.
Yeah, so Sjors, I've seen you've been doing a lot of interesting work recently. You've written some articles and you've been talking about things like hardware wallets. I thought it'd be great to get you on for some discussion. So maybe you want to just tell us a little bit about how you got into Bitcoin Core development.
Yeah, let's see. I think I started getting involved into Bitcoin Core in sort of August, September 2017, sort of around the UASF drama. Mostly by coincidence. I was actually playing around with something called the Drive Chain by Paul Stortz. And as I was experimenting with that code, I wanted to fix a test in Bitcoin Core for some reason. And so I did that. And then from there on, I just did more, mostly reviewing, but also contributing some pull requests. And then towards the end of the year, Blockchain.info, which is my previous employer, offered to sponsor me to keep doing that. So that's been fun.
Right. And so previously, what time period were you working with them for directly?
Directly from late 2014 to mid 2017.
I see. Yeah. Okay. And so on their side, you were more doing like application development on their side, or what were you doing there?
Yeah. So when I joined, they had a web wallet that was built in mostly jQuery and HTML, and I helped at the time partially rebuild that into AngularJS. And I think now they've done it all over again in React.js. So you have to keep working on these things. Right.
I see. You've just got to. It's just that process of continually updating and so on.
Yeah, I mean, the wallet has gotten a lot more complicated as well, right? So you start with the simplest thing, and then as you add more features, at some point the whole foundation just has to be redone. That's often how that goes.
I see. So let's talk a little bit then about what you've been mainly working on, thinking about, reviewing. Let's talk a little bit about those.
Yeah, I don't know what you want to, if there's anything specific you're interested in. I mean, we could talk about hardware wallets, for example. I've been looking at that most recently, so that's probably freshest on my mind.
Okay, sure. Let's go into.
But we can go into history, and maybe because it's a nice inspiration of how could you get started, right? I think one of the first feature pull requests I did was something extremely trivial, you'd think, which was to enable RBF by default in the graphical user interface, which is just a matter of changing the default in a checkbox. But if you look at that pull request, I think there's like 100 comments about it. So one of the things you'll learn is that people start bike shedding over the exact wording and whether the default should apply only to the graphical user interface or also to the command line system, et cetera, et cetera. So that was a really interesting way to get started.
Yeah, okay. So what, in terms of your background, like having been a developer for, professionally a developer for some time. Was that a difficult process for you to adjust to, or were you already you had already been doing sort of open source development and used to that kind of mechanic of review comments and so on?
I don't know, actually. I mean, for me, the one barrier was that I just had to learn a lot of C++ from nothing, essentially, because I have more experience in Objective-C, but it's quite different, and Ruby and JavaScript and some of these things. So just learning C++ is a lot of work, and then trying to understand the code base is a lot of work. But the nice thing about all this feedback is that you learn, right? So every line of code gets a comment essentially saying, hey, you should do it maybe this way or that way. And then you read a bunch of documentation. And so the feedback is actually quite useful if you're trying to ramp up your knowledge.
Right. So, what would be a good place to start then? I know there are various talks. I think there was one done talking about here's the overall architecture of Bitcoin Core, that you should learn that before then you try and fiddle around and actually.
I would say compile it locally on your own computer. That's the first thing. So you check out the Git repository and you build it, and you probably need some dependencies on your computer. And once you figure that out, you start the thing in Testnet. You put some coins on it, and then I guess the first thing you'll do after you've done that is you look through the open pull request, so the things that are already there, and you find something that looks simple enough that you can review it. So probably the issues have tags, so they might have a tag like UI, so user interface, or wallet, kind of the thing that's easy to understand what's going on. And maybe the pull request will say fix typo in menu entry, right? Let's say that's the name of the pull request. Okay, so you need to find out figure out how Git works. Kind of how do you check out somebody else's code, adding a remote. It's not rocket science, but then that's why it's nice to pick a simple issue, so you can focus on figuring all the tooling out. Then you build their version, and you check by running it yourself. Hey, is this actually fixed? So then the minimum you've done is at least test it, because if it doesn't do what it's supposed to do, then you just write a comment on the GitHub ticket saying, hey, I'm not seeing this fix. Looks like you missed something. So then you don't even need to review any code because it doesn't actually fix it. And then you can look at the code differences and try to say something intelligent about that.
Right.
And then you just pick a more complicated one. I find reviewing quite useful. Just lots of testing. You become familiar with the code as you go. And then you can read some documentation if you want to. But there's not that much documentation. It's mostly the code itself.
Right. And you mentioned also you've done some reviewing. What sort of split do you do in terms of writing new code versus reviewing existing?
It's hard to track, and it depends on my mood. But it's probably like 3-to-1 reviewing to writing code, if not like even a stronger ratio. The other thing about reviewing is it's quite addictive, because GitHub, once you review something, you leave a comment on a GitHub issue, and then you get notifications when somebody else leaves a comment, and so you tend to check on those comments, and then you've suggested a fix, then the author actually makes the fix, and then says, hey, I fixed this, so you try it again. And so it's quite easy to get into this sort of cycle of testing stuff, testing whether now the fix finally works.
Yeah, sure. And so the other thing that I've often been interested by, or just wanting to understand how that works, is I understand that at any given point there may be many different pull requests, and there may be many different things all happening at the same time in that Bitcoin Core repository. How do you try to keep keep that all conceptually in your mind at the same time, just to understand, if we put in this change, but then we've also got to consider there's this other potential change, that kind of thing?
Mm-hmm. Well, at the simplest level, that's a problem you have to deal with your own pull requests. So I think at the moment, I haven't checked now, but I think I have maybe about 10 pull requests open. Some of them like very simple text changes, others a little bit more complicated. And whenever somebody changes something else somewhere else that gets merged into master, at some point my changes will no longer be compatible. So then you have to do something called rebasing, which is you kind of take your changes and you replay them or rebase them on top of the latest version of the master branch, right? And sometimes that's trivial, And sometimes it's really hard because something completely changed from under you. Like for example, the way the documentation is put into the code that could completely change, and then you have to figure out what changed. I mean, the changes are always incremental, right? There's one master branch, and basically at any possible time, in theory at least, it could be released. So it always has to be in a working state. So that's nice. Now, there's also other pull requests that are not merged yet. So what I just described is if I have a pull request and somebody else changed something and that is merged, then I'll be the one who has to fix it. But let's say you have two people who are working on two different features, but that have some code in common. Then you kind of get in each other's way, right? And then it depends on who gets merged first.
It's a
In
race.
theory, it's kind of a race, but obviously, you try not to be stupid or annoying. And there's some nice tools recently added. I think it's pronounced Drabot, but I'm not sure. It's by Marco Falke. And what it does is it's a bot that crawls through all the different pull requests and looks at conflicts between pull requests, and then it'll leave a comment basically across those two pull requests. So if pull request A is incompatible with B, it'll leave a comment on A saying, hey, maybe you should also check out B. And it leaves a comment on B says, hey, maybe check out A. So that kind of encourages you to have a look at what this other person is doing.
Right. Yeah, that's interesting to learn a little bit further about this. I think I only had a very basic awareness of this, having done just Andreas's book Mastering Bitcoin a little while ago. And in that book, he, as part of the process, you actually you download you use Git and you download Bitcoin Core and you build it from the from that repository. So I have yeah, but I suppose in that book, what it's doing is essentially teaching you how to download the latest version. Whereas what you're talking about more is like actually how would you go about setting up your own little branch, running your own little tests in that, and then once you're sort of satisfied with that, that's where you may then make the pull request for it to then, once it's gone through the right levels of review, to then be merged into the master.
Right. And as the pull request is being reviewed, you'll probably have to keep pushing updates to keep up with what's happening on master. Though you generally only do that when Git complains. So GitHub will tell you at some point, hey, I can't automatically merge this, because Git is pretty smart in a lot of things. If somebody adds one line in the same file and another person adds another line in the same file, Git can usually figure it out. You don't have to do anything. But sometimes you're really just editing the same line in two different ways, and then you have to do something about it. And GitHub will tell you, and all these other tools will tell you.
Right, I see.
So it's a surprising amount of plumbing involved in software development, and especially when you have hundreds of people sort of getting in each other's way. Though at the same time, there's so many different areas of the code and so many different things that need to be done that quite often you can all change something without getting in each other's way.
Right, because you're all working on your own little separate pieces.
Yes. So it's interesting that people, I guess, have different motivations of what they're working on. And of course, you need some level of review in order to get anything you're doing merged. So maybe you try to figure out who the right person for that is, and maybe you help review some of their work, and maybe then they'll review some of your work. But you can't force anyone. So there's some really great pull requests. I can't really think of examples right now, but that have been open for more than a year, because there's not enough people reviewing it, or sometimes somebody does review it, but then the original author might be, occupied for a few months and not actually change the things that need to be changed. And then by the time they finally get time to change what they need to change, then the reviewers are gone again. And so these things can drag on for a while. But sometimes people are all excited about the same thing, and then review happens really quickly and really back and forth. So it's nice once you have the momentum. That would be my advice. Keep the momentum going. Like if you receive feedback and you have the time to fix it immediately, just do it immediately, because then you might just keep the ball rolling and get it merged fairly quickly.
Right. It's sort of like strike when the iron is hot, hey?
Yeah.
So what are some examples of things, right now that you think are quite, there's a lot of people interested in them?
So there's this new thing, I don't know if you've talked about it in an earlier episode, called descriptors.
No, I haven't actually. Yeah.
Okay, so descriptors are a way to describe, I guess it's to describe how you turn a key into an address in an abstract way. So normally, if you have the old style addresses that start with a 1, you take a public key and you take the hash. And so you would describe that as sh opening bracket, public key, and then closing bracket. Or you would describe it as sh opening bracket and a private key and a closing bracket, because the software will understand if it has to take the private key, turn it into a public key. Or you can use these deterministic hierarchical wallets. So then you might say sh, and then you start with the master key, and then you say /0/0/1/ whatever the derivation path is. And for SegWit, it would be called WSA, as in the witness. WPK, the witness public key hash. So that describes the SegWit address, the ones that start with BC1. And there's also a way to write down what a multisig address looks like. So take multisig of these two keys, and you need one of them. And that abstraction is pretty helpful. So what we find is that there's a lot of commands in the wallet, say for importing new keys or for scanning certain things. And also in the future for hardware wallet support, you also need that type of abstraction. So what you see is people are adding it to all sorts of places. So there's existing commands in the client, and now these commands are giving this descriptive functionality, and people seem to be, at least 2 or 3 or 4, whatever, people seem to be excited about that. So those changes get a lot of review quite quickly.
Yeah.
But there could be entire areas of focus where there's an entire sub community super active, and I wouldn't even notice it. It's kind of like on Twitter, right? You have these little bubbles where once you dive into the bubble, you see a lot of activity, but it's not showing up on your timeline.
Yeah, I see. Okay, so let's go now to hardware wallets. So I know that's something you've been doing talks about and just doing some work on. Do you want to give a bit of a background on what is it and why?
Yeah, I guess I could start with the why. So the nice thing about running your own full node is, that the thing you have is actually Bitcoin. You're checking all the transactions yourself. It's kind of how you're supposed to use it. But the problem is, where do you keep your private keys? And if the answer is on a hard disk on your Windows laptop that you're carrying around to every coffee shop you're going to, that's not optimal, I guess. So hardware wallets, on the other hand, are dedicated devices that keep your keys safe, kind of. At least they're not on the internet. And there's all sorts of talks of what could go wrong with them, but I think they're still much better than a insecure computer that you're using daily, and you might be installing all sorts of stuff on, maybe accidentally put malware on it, etc. The problem with hardware wallets, though, is that they have their own software support. So when you insert the physical device, something has to open on your computer, and usually that's kind of a website inside of an application. And that website, what it usually does is it sends the public keys of your wallet, the master keys, the account keys, sends them to the server of the company that made the hardware wallet. And then their server figures out what your balance is. And that's how you see, when you plug in the hardware wallet, you very quickly get to see your balance. And that's a very good user experience, maybe not a good privacy experience, because now, their server kind of could know the correlation between your IP address and how much Bitcoin you have. And then they've also shipped the wallet to you, and some overly curious law enforcement agency might then try to put those pieces together and figure out, or some evil hacker figure out who the good targets are. So from a privacy point of view, that's not ideal. And you don't get any of the benefits of the full node. So the idea would be to try and combine that, and that's been on people's wish list, I think, forever.
Yeah, sure.
And I think it'll be a while before it's really ready. But that's why. So the question then is how to do it. One of the things is there's no universal way hardware wallets communicate. Like usually they're USB, but they don't fundamentally have to be USB. They all have different drivers, different protocols, etc. So do you then want to, take every single hardware device and put the driver right into Bitcoin Core? That would add a lot of dependencies and a lot of extra code. And then you kind of have to keep track of the manufacturer, making sure they're not making any breaking changes. And the manufacturer might be releasing software updates very quickly, but Bitcoin Core moves at a slower pace. So that's probably not a very practical way yet. Maybe one day there will be a standard, and then maybe we could add 500 lines of code to Bitcoin Core that just works with every single hardware wallet out of the box. But there is a slightly different solution now that I think people are interested in, at least, and that's a work by Andrew Chow. And what he did is he wrote a Python library, and that Python library kind of pulls in all the Python drivers from, I think, about 5 different hardware wallets. And so it creates a universal wallet. So you call that command, I think it's called HWI, and you say enumerate. And then it just looks at all your USB ports and says, okay, I can see this device and this device. And here's the fingerprint of this device, so you can identify it. And then you can call a new command that says, give me your keys, your public keys. And that'll work on every device. So now you have a universal way of communicating with hardware wallets, which is nice. And now the idea, just the way I'm seeing it, is we take this universal way of communicating, so not necessarily his driver, but just the way his commands work. So anybody could make something similar. And then we make Bitcoin Core talk to that. So then all Bitcoin Core needs to do is be able to talk to a external application and say, give me your keys, sign this transaction, please, etc. But the external application would not be part of Bitcoin Core. So it's still the user's responsibility to download a driver for their wallet, for their hardware wallet. But Bitcoin Core would have one way of communicating to this.
Right. And I think
I might have to re-explain that in some other way to make a little bit more sense.
I think I'm mostly following. But I guess just to try and sort of bring it back for the average listener, it might be that in the past they might have used, like, let's say they were using Armory and they were using offline Armory, and in that model they had to have an offline computer with the keys and then bring that over, using a USB, and then bring that offline message to the online computer to broadcast a message.
Yeah, but even that was not that easy, right? It involved a lot of, probably, I haven't actually looked that deeply into these techniques, but it probably involved a lot of command line magic. And so, I mean, in principle, there's nothing wrong with having an offline laptop, to use as your hardware wallet. But even then, you want it to be easy. You want, for somehow, if you just plug this thing in and you enter a few standard commands and it just works, TM.
Yeah, sure. And I think the other component that I think might be interesting to touch on is this concept of PSBT, the partially signed Bitcoin transaction. Could you outline a little bit on that and how that relates?
Right. So there's indeed a couple of ingredients I think we need in order to be able to use hardware wallets with Bitcoin Core in an easy way without putting in too much new code into Bitcoin Core. So one of them is some standard way of communicating with a driver. So some sort of command that accepts calls like enumerate, give me your keys, sign this transaction. But the other is, how do you communicate to transactions themselves? And that is again work by Andrew Chow and I believe someone else too, which is a standard called partially signed Bitcoin transactions. And what that does is it takes a transaction, like kind of literally what it says. It takes a transaction that is not signed yet, or if it's a multisig, like part of it is signed, and communicates that in a format. So then, for example, your Bitcoin Core wallet might know all the public keys, so it creates a transaction, but it doesn't have the private key, so it can't put the signatures, and it uses this PSBT format to say, okay, this is what I have, this is my draft transaction, gives it to the hardware device. The hardware device says, thank you, I understand this format, let me add the keys for you, and then it gives it back.
Right. And I guess the other question people might be thinking is, why bother with hardware wallet support in Core? Is it that Bitcoin Core has a more well-reviewed software, and therefore it's kind of easier to for everyone to sort of use the main software that way? Or what are some of the benefits there?
Well, if you want a full node, then you have to use either Bitcoin Core or some other full node implementation. So you don't really have much choice, right? And if you then also want the security advantage of a physical hardware device, well, then you need some way to combine them, or you get the privacy trade-offs I just mentioned.
Yeah, exactly. Yeah.
And indeed, perhaps also the review. I mean, I don't know. Some of the popular hardware wallet companies, they probably, they have open source all their work and they do get a lot of eyes on it too. So I don't necessarily want to do a like, oh, Bitcoin Core is more secure because it has more review than that specific wallet. I just think fundamentally a full node plus a hardware wallet is a very natural combination to have. It's a very strong combination. And I guess in the beginning it'll be more for advanced users, but at least I want it to be easy. Like I like it to be, from a user point of view, you would open Bitcoin Core, which is just a graphical wallet. Looks a little old-fashioned, but it's not terrible. Then you plug in your USB key, and then you have some menu entry that says like pair hardware wallet or some language like that. It automatically finds the hardware wallet. It just creates a new wallet, pops open on your screen, and then you can just create a receive address. You can unplug it because you can just simply receive on it now. And then when you want to send a transaction, you just use that wallet as always. And it says, hey, plug in your hardware wallet. You plug it in, you click OK on the hardware wallet, and boom, it sends out the transaction. That's how I would like the user experience to be. And all the plumbing is what I talked about.
Yeah, no, I think that sounds like a good improvement, mainly on the privacy point of view to me.
The descriptors come into play there as well that I talked about. So one question is, how does the hardware wallet tell the environment what its keys are? And descriptors could be one way, universal way for the hardware wallet to say, okay, this is the series of keys you should use. And I don't know if you're familiar with all the different derivation standards for that. So BIP 44, BIP 32, that sort of stuff. There's different ways to go from the master seed to the actual addresses. And there's some commonality between wallets, but it's not exact. And some wallets might have their preferences. So these descriptors can also be used to express those preferences, to say, okay, use this derivation path for this hardware wallet.
I see. Yeah, so it's sort of saying, oh, okay, this is the style that Trezor are using, and this is the style that Ledger are using, and so on and so forth.
Right, and maybe some wallet doesn't support SegWit or some new future feature that we might have. Like, I don't know, maybe there's Sjors signatures, and maybe some hardware wallets support it and others don't. So they could also use those descriptors to kind of indicate what stuff they can do, and then Bitcoin Core can figure out what the best solution is then. Maybe not use this new address format.
Right. And I understand you've been doing your own experiments with this as well to try and, to prove it out.
Right. So I have a proof of concept pull request out to Bitcoin Core that basically makes the changes inside of Bitcoin Core that are needed to talk to the scripts that Andrew Chow wrote. And it kind of works. Like, you can use it on testnet, and you could use it on mainnet, but obviously that is at your own risk. But feel free to try it on testnet. But that's still only at the command line level. So that's still when you're talking to Bitcoin Core through the command line. And what I really want to get to is having this work in the user interface.
Right, I see, yeah.
And then there's basically a pile of other pull requests that are out there that I kind of need to be merged in to build on top of. So then, I tend to focus my review work on those pull requests, so make sure that those get merged, the stuff that's upstream. Because otherwise it's too much stuff to wrap your head around all the prerequisites.
Right, I see. And so it tends to be that, people have a certain specialization or something they're interested in, and then they tend to review and code things in that same area.
Yeah, I think that's kind of how that goes. You should maybe one day, if you can, talk to, say, Matt Corallo. He worked, he's been doing a lot of work on this new standard for miners, the better hash for mining pools. And, he makes a lot of changes. I think he made a lot of changes, especially last year, that are kind of little prerequisites to move in that direction. So that you can see that pattern. I'm not saying everyone does that.
Yeah, no, but that's totally, I think it's fair enough, because, everyone's got certain interests that they are into, and it makes the most sense to work on the things that you're most interested in. So I don't blame anyone for that.
Yeah, and there's so much to choose from, right? And there's nobody in charge that says, hey, you 3 people, you need to work on this thing. I would say that I think in a lot of companies, it works exactly the same way. There's a lot of times engineers are expected to kind of understand what they should work on, have a sense of responsibility.
Right, I see.
And it's not as top down as some people think.
Yeah, sure. Okay. All right. So anything else you wanted to mention in terms of hardware wallets or Bitcoin Core development?
No, I mean, if you have any questions about anything else there, let me know.
Yeah, well, I think maybe it might be a good time to just talk a little bit about, what's coming up in terms of Bitcoin Core. What are some interesting things that you might see coming? And I suppose actually let's maybe start with a little bit of a more open question. What do you think is likely to get merged in this year into Bitcoin Core?
So that's always unpredictable, I would say. I don't know. I mean, I hope some of the prerequisite stuff for hardware wallets makes it in. I think the changes are simple enough that they could make it in this year, but it does depend on how much people work on it and how much people review it, and if people agree on the concept. So it could be that there might be some more difficult, some hairy security trade-off that you might not immediately agree on. Say, do you call an external command, or do you call a server or something like that? And if those type of discussions can slow things down a lot, because generally when people can't really agree, then the default is to just kind of hold off and wait for some new information. But if you look at the open pull requests right now, there's 255 of them, and most of them are like surprisingly nitty gritty. So when you ask what's going to get merged this year, it's going to be mostly very small, random seeming stuff. Like some improved. If I just look now, I see something related to probably Windows UTF-8 support or.
So how about this one then? Aside from the hardware wallet stuff, what's on your wish list for merging into Bitcoin Core?
Well, my own stuff would be nice, but other stuff too. Like I said, basically anything related to that hardware wallet stuff. So that means anything related to descriptors. One big thing, Peter Whaley is sort of taking the lead on that one, which is really revamping the wallet itself. Because the wallet is one of the older components and quite confusing. And there's some good ideas on how to make it better. Also using those descriptors as a way to describe what is in the wallet. And the nice thing about that is generally when code gets refactored, it's just easy to read. Right now, it's still really, really hard to understand what the wallet is doing. Now, in terms of bigger features, like I'd love to see things like Schnorr and Taproot. I think are one of those types come in to the code, but I feel like I can't really do anything there. Like I can test it, but I don't understand the cryptography well enough, so I can't really review it at that level. So it's really just waiting for the 2 or 3 people in the world that can actually write that code and actually do it, and then I'll happily review it as quickly as possible and find any obvious problems with it. But that's about as much as I can contribute to those things. And unfortunately, the people who have to do this, they also do a lot of other things. So I guess what I can do there is at least try to take some work away from them there, so they can only focus on the things that they're exclusively good at.
Yeah, that's fascinating. I guess it's just a very highly specialized field, and there's just literally just not that many people who can do that.
Mm-hmm. Yeah, there's a smaller one, for example. This has been open for more than a year and has to do with how the settings are saved. Gets a little bit nitty gritty, but if you open the wallet, the graphical wallet, there's a bunch of, you can have a configuration file and you can put settings in there, but there's also settings that are stored in the graphical client itself. The problem is then if you close it and you start the non-graphical version, and it doesn't remember those settings, and that creates some bit of a mess. And there's a nice pull request by Luke Jr. that fixes that. So that's one I would like to see merged. It's getting more attention recently. So
let's save a bit of time now to speak about one of the articles you've written recently, which I thought would be good to discuss. So you wrote this article called "A Crime on Testnet." Can you just give a bit of an overview on that?
Yes. So I'm just opening it right in front of me also to remember. So what I did is I recently, I'd say over the last year or so, I've been reading sort of Dutch court cases that are published, and they all involve mentions of this mythical Chainalysis thing and similar tools that have been used to bust people who were accused of money laundering. And from reading the problem is when you're reading these published documents, you don't really know you don't know everything. They're not, they're written by somebody who's probably not technical, who's just there to write down what's being said in court, and probably during the court hearing itself was already confusing enough. we don't have video recordings of these things. So it's kind of hard to reconstruct what's going on. But my impression is quite often that they're too optimistic about how good the evidence is from these tools, especially for in a criminal case where you really have to say, okay, somebody actually laundered money. You can't just like a lot of these tools are meant for exchanges to just do some risk guessing, saying, maybe we shouldn't, maybe we should ask more questions to this customer or more questions to that customer. Then it's fine if you're wrong every now and then. But in a criminal situation, you can't have that. You have to have strong evidence. So I got pretty critical of that. But then I decided I need to articulate my criticisms a little bit better. And how do you do that? Well, so what I came up with is I wrote a blog post called a Crime on Testnet. And there I am describing a hypothetical, simple scenario where it starts out with somebody who wants to drink coffee. And we kind of imagine a dystopian future where that is totally illegal. And how does he do that? Well, he knows a guy, and the guy takes Bitcoin, so he goes to the guy. He buys his coffee. Well, first he has to buy the Bitcoin, so he goes to a regular website because in this future that's perfectly legal. He buys the coins. He buys his coffee. And at the end of the day, the coffee guy has a bunch of coins in his wallet, and he needs to do his own shopping. So he actually wants to go back into the fiat system. But he cannot use the online exchanges for some reason, and so he needs to find someone who takes Bitcoin for cash. And then I kind of moved the story following the guy who's taking the Bitcoin for cash because he's actually the main character in this story. So the guy who takes Bitcoin for cash, he's trading with our coffee guy, but he's also trading with an undercover police officer. And then at the end of the story, we kind of look at the blockchain where the undercover police officer says, hey, I'm seeing my transaction and I'm also seeing some other transaction, and I can see that these two are related. And therefore, I'm going to assume that all of that was your volume for the money laundering. Right? So you kind of drip a little bit of coins into somebody's wallet by doing a trade with them physically, perhaps. And then you say, oh, now I can see the total size of your wallet, and therefore, that's what we're going to convict you of money laundering that amount. That's kind of how that works in a nutshell. But then, yeah. And so in this story, and I guess that's because it's the first version, and I'm trying to keep it simple. In this story, it's actually correct. Like, the analysis actually finds the coins that are actually from this person. But in reality, things are much more murky, or could at least be a lot more murky. And so that would be a follow-up, but this story is already long enough, so I was...
But I think that is really highlighting the difficulty with this kind of clustering analysis and the use of these sort of the merging heuristic to say that, well, because all these 4 inputs were used in this transaction, that now, you are the owner of all of those.
Yeah, so basically the heuristic is then if multiple inputs are used in the same transaction, well then somebody must have signed that transaction, therefore that is the owner of the funds. But an easy example and so the example here, it's correct, right? So our trader has a wallet. He receives 2 different coins, 2 different inputs for his new transaction. He combines those into one transaction, and he was the one signing that. So he actually took those 2 inputs and sent them somewhere else. And so that proves that those, and so in that case, those 2 are related. But let's say that instead of, that it wasn't our trader's wallet, it was a custodian wallet. Say it was using Coinbase. So now what happens is the customer, the undercover agent sends money, but unbeknownst to this undercover agent, he's not sending it to the trader, he's sending it to Coinbase, the trader's address on Coinbase. And so does our coffee dealer. He also sends coins to Coinbase. Now the agent comes back at the police station, looks at the blockchain, and he sees all the transactions from Coinbase. He's like, whoa, this guy is doing, billions of dollars in laundering. What the hell's going on? So that's one thing you can misinterpret it if you don't realize that you're dealing with a wallet that manages keys on behalf of multiple customers. Another thing that could happen is maybe somebody's using a mixer because they care about their privacy. They don't want to get robbed. Because now I can see exactly how much coffee this guy sold. It's not something you want, right? So maybe he would use a mixer, but then other people are using the mixer. So now if you're starting to look at the blockchain, it might look like that entire mixer is part of the deal, or that's kind of the ways these things can go wrong.
Right. And so I think the other question then is, do you think it's likely that police and law enforcement have individuals who are sufficiently technically capable and knowledgeable about these factors that you were just describing?
Well, that's hard to tell. I mean, first of all, not all these cases are public, and I guess what happens in court is you have other people doing the talking. So I don't really know what the actual expertise is. It might be that there's like somebody who totally understands it and writes a bunch of things down and goes through a Chinese whispers game and it turns into nonsense. Yeah, I mean, my guess would be that they have these tools and they kind of know how to use them, but they don't really understand all the pitfalls because the pitfalls are pretty hard to explain.
Yeah, definitely. I think it's something that definitely requires a certain level of technical competence, a certain level of intelligence, there's a certain level of skill required to really correctly understand these things. And even at the same time, there are guys working on things like pay to endpoint and so on that will even then go and ruin that kind of analysis as well.
Yeah, but the question is, who does it ruin it for? And so far, if I'm looking at this, it's ruining it for the traders because anytime you create plausible deniability in a money laundering scenario, the burden of evidence is reversed. And so, uh, rather than you would say, "Oh, how do you know it was me?" The burden of evidence is reduced, and they're basically saying, "Okay, you clearly use some sort of mixing technology that makes you a suspect." Therefore, you now need to prove that you actually did something legitimate here. So tell us what you did. And so then all these techniques don't really work, in my opinion. So it's a nasty legal problem. And I think usually the way the court system should work, in a sort of an ideal society that, assuming you don't want assuming you do want some sort of criminal justice system, what should happen is the lawyers on the defense side should start arguing what's wrong with this analysis and should start defending things like presumption of innocence and a burden of evidence being on which side the burden of evidence should be, and that discussion should be had. But it's very difficult to have that discussion if you don't understand what the hell is going on. If you have no clue how the blockchain works, then you don't understand whether or not you're still being reasonable in what burden of evidence you're putting on what side. And so you get really weird court decisions where the judge might say, "Oh, just use a different tool and see if it shows the same result." It's like, well, that's almost like these little witch sticks where you can find where the water is. That's not the right level of analysis, basically. So what I would like to see, I guess, what needs to happen eventually is that the expertise has to go up. So the defense has to understand how these tools work, have to understand their limits, and then they can actually defend their clients. And then the other side will automatically, of course, also have to level up their game because at some point they're going to lose a few of these cases. Well, then they're going to start reading about the pitfalls themselves, and they'll say, well, yeah, we know this mixing thing, but we thought about that, and here's the extra evidence that we collected, and this does prove that it wasn't a mixer, or it was this person. So it's a cat and mouse game, and I'm not like advocating any outcome. Like it might not end well for the people doing the trading, but I would like at least to see these trials become fair again. And I think we're a long way from that because this technology is complicated. It's moving really fast. People are adding more layers of privacy, which is a good thing, but it also makes it more and more and more difficult to understand.
The other complexity then as well is things like, Lightning Network and so on that
Oh
take
yeah,
it to
I,
another
I would
level.
love to do a follow up for that, just to show. Okay, let's redo this scenario, and now what happens is instead, all the players have Lightning nodes, and they don't necessarily even have channels with each other, and they don't necessarily immediately settle the channels. So somebody could just send a lightning payment and then get cash for that, or there's no on-chain evidence. That would be the first step. Is like, yeah, this is weird. We don't really see what's going on. But then the second step, of course, the cat and mouse game continues. So now the cops are starting to monitoring the IP traffic. If you're using your mobile phone, that mobile phone is pretty revealing pretty much anything it's doing.
What about VPNs on the phone or Dandelion even? So
VPNs. I'm super skeptical of VPNs because that means you're sending all your information to a single company that can now be subpoenaed. So that may or may not be in your advantage. And maybe you can play some geo-arbitrage, saying, well, I'm in country A, I use a VPN to country B, which means law enforcement kind of has to go around, to country B to get that information. Yeah, that might work, but it could also be the opposite. Maybe the VPN company decides to blackmail you.
Yeah, true. That's the other side of that coin.
But also, I guess maybe eventually the cat and mouse game might just go back to the physical world. Like if you want to catch someone doing something illegal, just catch them in real life.
Right. And so it would just be, I don't know, police trying to catch people doing local Bitcoin transactions or something.
Yeah, exactly. You just arrest them and then you ask, what were you doing? They say, well, it was just a friend. Okay. I don't know. But yeah, you can just go back to, look back at, say, the Silk Road. Like, everybody was using Bitcoin, but how was that, how was Ross eventually arrested? He made a mistake by using his personal email address on a forum like years earlier. Nothing to do with Bitcoin. So people make mistakes, and if you have a state actor essentially with infinite budget, and all they need to do is just look at you and see what you're doing, and then many actual criminals have a habit of bragging about what they're doing to friends or on Facebook, so they're creating their own evidence trails.
Yeah.
But that is more work, right? It's probably easier to just, I don't know, make a list of all the local Bitcoin traders, go to all of them, make 3 trades with all of them, run this trace chain analysis, and just arrest 50 of them, and then show some pretty pictures to the judge, and then have them go to jail for a few months. That's very efficient if you're trying to get a lot of convictions very quickly.
I think I asked a similar sort of question to Adam back, but I was basically asking around this concept of, let's say we don't get confidential transactions, but we get a combination of other things. So let's say we have Dandelion in terms of the IP protection, or at least some level of protection from that that kind of attack. And let's say more and more people use
or just Tor.
Yeah, and more people use Tor, and more people use Lightning Network, obviously, and more people just start using things like Join Market and Wasabi Wallet, and these kinds of products that do a little bit of the fancy coin join and so on. Do you think let's say a few years down the track, would that sort of behavior or that sort of transactions be identifiable to somebody unless they had like a lot of resources? Or do you think, realistically, they're going to make similar sort of mistakes like Ross would?
So there's one interesting dynamic here that might be worth pointing out, and that is the plausible deniability argument. If you're using a mixer, you're putting effort into using that mixer. Right now, I personally think privacy is like a human right, and I think the law also thinks that. So you should be using mixers, and it should be considered a good thing, and you should be protecting your privacy and your customers' privacy. But at the moment, the legal system, at least in the money laundering sense, doesn't agree with that.
Right.
It basically says if you use a mixer, you have something to hide. Now, so that's a legal problem. But now you get something like Lightning, and Lightning is cheaper and faster. And so you're getting privacy, yes, but you're also paying less. And it is not suspect to pay less for something. Like you can't just, ask someone, hey, why did you pay less for this thing? So it has this convenient, plausible deniability benefit. So you use a nice privacy improvement, and you have a good excuse, even in a fairly dystopian scenario, to use that privacy solution. Now, with what could be interesting on-chain is the signature aggregation stuff, where eventually you can have a transaction that might have 100 inputs, and now you need to put 100 different signatures on it, but eventually maybe we can make that one signature. And so that will make it cheaper to combine your transaction with other people. So it's like compression.
Yeah, that's a fascinating idea as well. But obviously that could take some time.
So then why are you using this mixer? Well, because I don't want to pay the $50 transaction fees or whatever they are.
Yeah, I see the point you're making. It's very much that you almost reverse the plausible deniability in some ways because you can't really expect that people just go out of their way to not use use that say the Schnorr aggregated signature.
Yes, exactly. And so it's an interesting potential long-term trend where because data is scarce, at least on-chain data is scarce, um, you have to reduce the amount of data per transaction essentially, because if the blocks stay the same size, then you want to have more people using Bitcoin, then the amount of data per transaction, at least the amount of data on chain, is going to go down with time. As a simple economic function. So that's an economic pressure that creates privacy. And I don't know if that's a law of physics or something. So some other trend could happen that completely reverses it. Facebook is the exact opposite, right? There's a financial incentive in Facebook to reduce your privacy. So it's interesting that Bitcoin seems to have this opposite property where financial incentives increase your privacy. Unfortunately, there's other levels. I mean, you could still monitor the network and monitor IP addresses and do timing and that sort of stuff. But at least it's a lot more work. And that would quickly enter the realm of mass surveillance, which, there's also some restrictions on that.
Yeah.
So maybe there's a reason to be optimistic, but maybe not.
Yeah, maybe. And I think the other one as well might be if more and more wallets start doing things like mixing by default.
Well, yeah. Well, not really, because why are you using that wallet, right? Now, if Coinbase started mixing by default, so then you'd have to have, from a political point of view, I think you'd have to have some like reputable, quote unquote, regulated, quote unquote, wallet that takes the initiative and says, hey, and that actually pitches that in a good way, which is very doable. You basically say, hey, we care about our users' privacy. We see people getting robbed because they revealed their Bitcoin holdings to some merchant. We don't want that to happen to our users, so we're adding privacy. And then once those reputable companies do it, then everybody else follows. But if what's happening now is if you have wallets that really promote themselves as we're going to defeat the government and we're going to do mixing by default, then you run into this plausible deniability problem that we talked about.
Right. Yeah, I see that.
But just to clarify, I think it's good that these privacy-friendly wallets exist. I highly encourage it. The political rhetoric is whatever. Just make Bitcoin as secure and as private as possible, please. Keep doing that.
Oh, yeah, definitely. I think this is more just a exploration of hypotheticals. The other question I was going to ask, and obviously I totally understand if you don't know or you don't have a real comment on that, but one disturbing sort of trend I've seen is, well, I think maybe a month ago or so, there was a listing of, I think, some cryptocurrency addresses on the OFAC sanctions list. And I think that's, yeah, and I think that's also quite a technically kind of challenging concept to discuss, because then it's how many hops before or after, or does it have to get cleaned by being bought from the government before it's now considered clean again?
So obviously I'm not a legal expert, let alone a US sanctions law expert, but I think people are sort of seeing too much into this. What I read there is that the OFAC folks said, hey, we have an identifier. There's a person that you can't do business with, and this guy, this is his picture, this is his passport number, and this is his home address, and this is his phone number, and by the way, here are 2 Bitcoin addresses that he uses. And that's not the same. It's not literally the same as blacklisting those Bitcoin addresses. It's just saying that if you are a financial service that does all sorts of monitoring of on-chain stuff, then you should also have a look at those addresses and then have some common sense way of determining whether this person is involved or not.
Right.
And then I guess is when you run this chain analysis tool or whatever, and it says bleep 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 bleep, this guy is involved, or this address is somehow involved, we think. Well, then it's not. I don't think it's necessarily that, okay, you block everything. No, what you do is you flag this transaction, and then it goes to your compliance department, and the compliance person looks at it and sends an email saying, hey, could you explain the source of these funds and where they're going? And then if a reasonable answer comes, maybe they'll be a little bit more aggressive in which questions they're going to ask, because they don't want to, go to jail themselves. But eventually, it's still just subjective. It's probably just humans deciding whether or not it goes through. I don't think people are talking about black and white filters for this, which wouldn't make any sense. Could evolve to that, but I don't think that's the case now.
Yeah, I see. I mean, maybe I'm not thinking about it the right way, but the way I was thinking about it was more like if these addresses have been, blacklisted, and let's say coins have, passed through, and I don't know, there is no such thing as, the from address. Obviously, there's, the UTXOs, but from the kind of naive and, chain analysis point of view, if they kind of interpret it aggressively and say, oh, well, look, these coins came, quote unquote, from that address, even though that's not technically what's happening, isn't there a little bit of a case there that they could try to argue, okay, look, this bank ABC, you should have blocked that transaction, or you should have reported it to the government because these coins came, quote unquote, from the OFAC sanctioned address?
Yeah, that's exactly what would happen. I think that's what I'm trying to say. But then if the bank says, hey, yes, we saw that, our systems detected that, and we asked some questions, and it was clear, like, not related because we got these answers, and these guys nothing to do with Iran, then, I guess then the government would have to, like, have a long court battle with the bank, arguing whether or not they did their due diligence correctly.
Yeah.
But I don't know if that actually works that way. I think
sure.
they just say, hey, we have a compliance department, and they followed procedures, and we did flag it. We then investigated it. We found it wasn't a problem. We let it through.
Right. Yeah. I see. Yeah. I mean, I see that. But I suppose the question then is, how many hops back are they expected to look? Would they just say, oh, so long as it didn't come from in one hop, then that's fine? Or would they start now doing some kind of risk-based approach of, oh, okay, well, it was 2 hops away, and then at what point do they just say, oh, that was 10 hops away?
Well, that gets to a fundamental question about compliance. Why is a bank or other institution complying? Are they doing it because they believe in the regulations and are trying to enforce the spirit of the law, and therefore they use something we could call common sense, which means, I don't know about numbers of hops. If you see something, ask questions. Don't be super strict, because if you say 6 hops, then somebody just makes 7 hops, right? If you're super rigorous about that. So I think in a common sense situation, I think people will be fine, because that's what common sense is. But what if actually compliance is something you want to be seen as? So you want to be seen as compliant, but ideally you want to maximize your revenue as a bank. So as a bank, you want to make as much money as possible, and probably people who are doing money laundering might be, better paying customers. So in that sense, you want those customers, but you obviously don't want the PR fallout, and you don't want to get in trouble with the regulators. Well, in that case, you're going to interpret the rules as strictly as you can. Don't spend too much money on it. But that could still work both ways, because on the one hand, you could try and maximize just the number of customers and not enforce anything, but then you occasionally get a fine. So then you have to do some risk-adjusted thing, like, okay, if we make this many mistakes, we pay this much in fines, so we want to reduce the number of mistakes. Then you get into something called de-risking. And that is happening in a lot of places. I think in Hong Kong especially, because I've heard a lot of stories from there. But what happens is a bank sees a new potential customer. If that is not the most Disneyfied standard business you could possibly imagine, then they'll just deny them, because they don't want to have even a 1 in a million chance of getting $1 billion fine. And if they start de-risking, then the criterion is, okay, if your coin at all has anything to do with any of these OFAC addresses, we're just gonna not accept it, because it's not worth it. For this 0.1% that we're making on this transaction, we have a chance of $1 billion fine. So we're just gonna deny most customers. That does seem to be what's happening.
Right, I see. And I suppose then
try opening a bank account as a Bitcoin business at all, regardless of OFAC. If you in your bank application say, oh, I use Bitcoin, just denied.
Insta deny, yeah.
Pretty much. And there's 1 or 2 banks that try to specialize in it, but it's really hard. And then once you have that banking relationship, there's going to be constant pressure on you to really behave in the nicest possible way. And that's probably also why things like Coinbase banning people from Gab It's probably banking pressure, because they cannot do anything to risk that banking relationship. So they're not going to go out and make a free speech stance, because it's just not like, and something else might be going on there, but just saying that's a general pattern. Like if the banks tell them to shut some customer down, then they're just going to do it.
Yeah, look, I think that's kind of the harsh reality of banking in today's world, because of the regulations, and these banks are basically living in fear of losing their banking license in some cases, and so
And fines.
yeah, big fines
Especially. So the Bitcoin companies are afraid of losing their bank accounts, period, which they might have spent years trying to get in the first place. And then the banks themselves are worried about massive fines, which presumably at some point hurt bonuses. So yeah, that's the incentives. And there's some counter movement starting to happen, because you see so many people getting de-risked that at some point government's going to say, hey, wait a minute, if you're a bank, you should probably accept customers. And I think Canada, maybe the Netherlands, has some right that you are entitled to have a bank account. I think in the Netherlands, what I heard is that every bank can refuse you, but the last bank has to accept you as a business.
Oh, really?
So
There's actually a rule.
you don't want to be the last bank. That's what I've heard. Which is hilarious if you even remotely think about it. And then I guess they can do whatever well, I don't think you can do whatever you want. If you do something totally crazy, they can probably terminate the relationship and make you unbanked. But it is problematic.
Yeah, fair enough. I see.
So there are some counter rules in that.
Yeah, sure. All right. Well, look, Sjors, it's been a fascinating conversation. I think it's been really enjoyable just to talk about some of the hypotheticals around, chain analysis and so on. Did you have maybe any closing comments? And also, obviously, you got to tell the listeners where to find you and where to find your blog as well.
Yes. Go help out with Bitcoin Core. It can be as simple as just use it once, put some coins in it, maybe not all your coins if you don't know what you're doing. Then it'd be great if people are keen on helping with testing. It does take some technical skill, but people might be willing to help out. And it's super useful just to simply test whether something actually does what it says it does. And then where people can find me, I think Twitter is the easiest. Provoost, which is spelled Provoost, and that has a link to my blog. But if you Google a crime on Testnet, you will find the blog article and therefore my blog.
Oh, yeah. And I'll definitely put the link for that in the show notes, guys. And I'll also link to Sjors' Twitter and also his blogs as well. So look, Sjors, as I said, it's been a great conversation. Thank you very much for coming on.
Yeah, thank you for having me.
I hope you enjoyed listening to some of the insights there from Sjors. Let me know what you think on Twitter or DM me. If you did enjoy it, you can help me out by liking, retweeting, resharing, giving it a thumbs up on YouTube, subscribing to the podcast, and giving it a review or rating, hopefully 5 stars. Those of you who want to donate fiat can use my patreon.com/Stefan Livera link to become a Patreon supporter and get access to a private Telegram chat group. And those who want to donate with Bitcoin or Lightning payments can donate using Tallycoin. That's tallyco.in/Stefan Livera. Show notes are on my website, stefanlivera.com, and that's it from me. Thanks for listening, and chat to you next time.